The broadcast is now starting. All attendees are in listen-only mode.
On behalf of RBCS and software test professionals, welcome to this webinar on myths of pairwise testing. I'm Rex Black, president of RBCS, a worldwide testing and quality assurance firm serving clients ranging from small startups to Fortune 20 global enterprises. Since 1994, we have delivered insight and confidence to hundreds of clients around the world. Our team of international consultants deliver customized training, consulting, and outsourcing services for companies that are looking to improve their test and quality assurance practices. I am the author of 12 books on software testing, including the bestseller Managing the Testing Process and 4 books on the ISTQB program. We are presenting this webinar in partnership with Software Test Professionals. Check out their website, www.softwaretestpro.com. Attending today's webinar may earn you credit for QAI and ASQ recertification. Check with QAI or ASQ to determine how to qualify. It typically involves saving the attendee email that you'll receive after this webinar. Attendance at today's webinar definitely earns you PMI PDUs if you need them. Thank you very much to Linda Thorne for reviewing the materials for PDU status and for making valuable suggestions. Attendees will receive an email telling them how to claim PDUs, including the PDU code. Unless you happen to be listening on a mobile device, there is still a bug in the Citrix software which causes it not to recognize that you have logged in and listened on a mobile device. Apologize for that. Please contact Citrix to ask them to repair this bug as quickly as possible. Before we start the presentation, some housekeeping notes. Feel free to submit your questions at any time, but please do note that I will only answer them at the end. You do not need to ask for presentation copies. The presentation is on the web, www.rbcs-us.com. Go to the Resources tab in the upper middle, and then from there navigate to the basic library. Also, by attending this webinar, you have been automatically registered for the next free e-learning drawing. Check your email over the next couple days and watch that spam filter. Now, if you are having problems with this webinar, please contact GoToWebinar Support at Citrix. Generally, the problems are either browser incompatibility, so you can try a different browser, audio settings on your PC, so you can adjust those audio settings, or company firewalls. But of course, if you had a company firewall preventing you from downloading the Citrix software, you wouldn't be hearing this anyway. I hope you enjoy this free webinar from RBCS. We do these free webinars as a service to the software testing community because at RBCS we are a not just for-profit company. Okay, so myths of pairwise testing. What is proper use? What is misuse? What is overuse? So, myths are interesting stories that reveal something about what people tend to want, right? So there was the fountain of youth, which allegedly you would dip yourself into and be restored to a young age. There was the philosopher's stone, which would turn lead into gold, or other base metals into gold. And then there was El Dorado, which is the city paved with gold, and you just pull your truck in, I suppose, and scoop up paving stones and throw them in the back of your truck and drive off. So software testing has myths, just like many other endeavors do. And one of those myths, or some of those myths, have been wrapped around this concept of pairwise testing, which has come into prominence over the last 10 years or so. So what I want to look at today is proper use and expectations about pairwise testing, situations that might constitute overuse and ways to avoid it, and also other techniques which might be just as good or even better and may very well be more efficient than employing the pairwise techniques. Okay, so if you're not familiar with what exactly pairwise testing is, pairwise testing involves testing all possible pairs of options for all possible pairs of factors. Now, I don't want to get into a long explanation of pairwise testing and how it works. I did that on a previous webinar about a year or two ago, and there's the recorded version of that webinar is in the digital library on the RBCS webpage. So feel free to go out and take a listen to that if you want to get a detailed explanation of what pairwise testing is and how exactly it works. Basically, it focuses on the possible interactions of pairs of options across pairs of factors or variables. So examples of this might be that you have a configuration variable that can take on say 4 or 5 different values, and you've got another configuration variable that can take on 4 or 5 different values. And so every possible combination of those different values that each of those 2 configuration options can take on will be tested. But if you have 4, 5, 6, 7 configuration options, you don't try to test all possible combinations, but you just go one pair of options at a time, or excuse me, one pair of factors at a time. So we've got, say, 7 or 8 configuration variables that we can check, and each one of them has options. So we just look at the pairs across the different pairs of variables rather than trying all the different combinations. There are various ways to go about doing this. You can use orthogonal arrays, but that tends to be more work than it's worth. You're better off downloading a free tool. You can find some at pairwise.org. I'm going to demonstrate the use of one such tool, the AXE tool, which is created by the United States National Institute of Standards and Technology, and is available for a free download. Well, it's your tax dollars at work, basically. If you're a U.S. citizen, you paid for it, so you can use it. Now, one of the things that you want to do in pairwise testing typically is identify options that are independent, meaning that the selection of one option for one variable does not constrain the options that are available for the other variables. This, of course, isn't always true. Often there are some constraints. So a tool that allows a somewhat specialized form of pairwise testing or pair generation tests called sometimes referred to as classification tree will allow for constraints and for weighting. And you'll find that the AXE tool does have that capability. That's one of the reasons why I think that's worth using. There is a classification tree tool available from Daimler. And they apparently use it for testing the Mercedes-Benz vehicles. And I find that more difficult to use than the AXE tool. The AXE tool is graphical, whereas the Daimler tool, which is called CTE, by the way, is more of a it's a hybrid of graphic. It's got a GUI on it, but there's a lot of it that's command line driven, and the learning curve is pretty steep. Anyway, the idea of pairwise testing is to say, well, I don't want to test all possible combinations because that's ridiculous. That's what's commonly referred to as the combinatorial explosion. But I do have to test some combinations. So, the combinatorial explosion, let's just illustrate that here with an example. Take a look at this simple input screen. This is from the Quicken financial application. Pardon me. It's fairly straightforward screen. There's not terribly many fields on it. Maybe about the same as your average screen that you would see while you're checking out of an e-commerce site. So it's fairly similar in terms of the degree of complexity there. But let me just ask you to say, all right, how many possible tests are there? If you assume that there are just 5 interesting equivalence partitions for each field, and though there are probably more, you're going to use equivalence partition testing, but instead of just testing the equivalence partitions, you're going to test all the combinations of equivalence partitions. Then how many tests would you have? And notice that this is just testing the equivalence partitions, not the interactions that would exist behind the screen, as it were, the calculations and so forth. So I'll give you a minute to think about that, see if you can come up with a number, and then we'll pop up the actual number up on the screen. I hear furious scribbling of people calculate away or clicking as they're calculating. We'll see how many people came up with the right answer here. So 1,953,125. Ouch. And because there's probably more than 5 interesting types of inputs for some of these fields, probably maybe all of these fields, you're actually going to have a much larger number. So it's probably in excess of 2 million unique screen combinations, and that's just selecting a single value to represent each equivalence partition. That's not even getting into all the possible values that could be in the fields. So that's a problem. So this is the combinatorial explosion, and this is where various techniques come in, and certainly equivalence partitioning by itself and with its extension boundary value analysis is one way of dealing with it, which is you just say, since the fields are supposed to be independent, I'm going to test them as if they were independent, that is, and I'm going to just use equivalence partitioning and boundary value analysis where I have a sorted field or ordered field, and call that good enough. And then I'll use some other technique like domain analysis and decision tables and so forth to test the business logic that sits behind the UI. But then some people say, and some pairwise tool vendors say, oh, no, we need to test combinations. We need to test things together. Well, let's look at that for a minute. Do we really? So a number of years ago when I was young and I guess more foolish than I am now, somewhat wiser, I had a job that involved traveling around the United States, and so what would happen is I would go, well, I still have a job that involves traveling around the United States a lot, but this was pretty much every week I was in a different place, and I had a routine. On Monday morning I'd arrive wherever I was going, and I would go to the car rental place, and I would install my radar detector, and off I went. And one week I was in Ohio, and I was going back from the airport, back to the airport from the client site, and was pulled over by the police. They shot me with a laser gun, which I'd never seen before. This was being the mid-'90s. And the policeman had this little handheld computer, which might not sound amazing now, but remember this is the mid-1990s, and he input various facts about me, including how fast I was going, which I will decline to mention here, and printed my ticket from that. And then when I explained that I would not be able to pay the ticket in person before leaving the state, he said, well, then you'll have to pay me because otherwise you'll be a fugitive if you leave the state without paying the ticket. And I asked him how to do that, and he demonstrated that he was able to take Visa, which surely he did on this little computer, and I gave him my Visa card and paid my bill. But that, retrospectively amusing anecdote aside, trust me, it was not amusing at the time, led me to think about how that computer might work. And so you can think that there could be some decision table implemented in that computer where it looks at various conditions about the person who's being questioned. I guess question sounds awful severe, but being talked to by the police, and to gather up various bits of information about them and enter them into a system. And the decision table, or at least a portion of it, might look something like this. Now, if you're not familiar with decision tables, I don't want to get too wound around that particular topic here. I would encourage you to go again to the RBCS Digital Library and listen to our recorded webinar on the topic of decision tables. It's all of these recorded webinars are available for free from our digital library, so you can go take a listen. The key thing to note about this particular decision table is it is what's called a non-exclusive table, meaning some of the rules can interact with some of the other rules, which is not the case in all decision tables. So, for example, Rule 1 and Rule 6 could be active at the same time, and in fact, Rules 1 through 4 and Rule 8 could all be active at the same time. And so there are a number of different ways that this can combine. And even this fairly simple table has well over 100 or so possible combinations, believe it or not, when you take the boundary values into account. So we don't probably want to try to test all those combinations, nor does it necessarily make sense to do so. So advocates of pairwise testing would say, hey, no problem, let's put this in a pairwise test tool and we'll test a bunch of combinations. Okay, so if I use the AXE tool, which is a perfectly good tool for this purpose, I set it up and you see a screenshot here of how it works. And the strength 2, by the way, means is generating pairs. I can crank up the strength if I want something, I want triples or quadruples. And you notice that the excess speed column, I have the excess speeds encoded. So A means the excess speed is 0, B means the excess speed is from 1 to 10, C means the excess speed is from 11 to 20, and so forth. What I have here is a table with 10 rows in it that shows all possible combinations of options across all possible pairs of factors. So in this case, the pairs of factors are license okay with warrant, license okay with registration okay, license okay with vehicle okay, and license okay with excess speed. Warrant with registration okay, warrant with vehicle okay, warrant with excess speed. Registration okay with vehicle okay, registration okay with excess speed, and vehicle okay with excess speed. All the pairs of options across all those pairs of factors I just listed are tested. And of course, each option is tested at least once too. Of course, obviously, if all pairs of options are tested, it's obvious that each option would be tested at least once. In fact, just by inspection, you can see that each option is actually tested at least twice, and in most cases, it's more like 5 times in the case of the Boolean or true-false options. So you might look at this and go, okay, well, that looks like a good set of tests. It does a lot of different interactions and so forth, but there's a problem. A basic rule of decision table testing is that you would test each rule by itself. So with a decision table, you want to have at least one test per column or rule. And then when you get into non-exclusive tables like the one shown on the previous page, you can test with some combinations. It also, while it will test the boundary values, or at least it will allow us to test the boundary values of excess speed, because notice we have 2 options for each, or two selections of each option. So for example, for D, we can have 21 in row 7 and 25 in row 8. So we can test the boundary values of the excess speed, which is nice, which we'd probably want to do in the case of a decision table test anyway. But notice that it does not test the maximum fine. We don't have any place where the license okay is false and warrant is true and registration is false and the vehicle okay is false, which would be the specific combination that we would need in order to force the maximum fine. And so that's not there. If you were doing domain analysis, then you would have that, because you would force that calculation to occur. Now, again, if you're not familiar with domain analysis, I would refer you to the digital library, and you can listen to a complete explanation of how domain analysis works there. Short version is that domain analysis involves looking behind the UI and analyzing the calculations that are occurring behind the UI, somewhat similar to how the decision table represents combinations of conditions. In the case of domain analysis, you're looking at combinations of actual numerical variables or other variables that are being used in equations somehow. So we've got 16 tests here, or excuse me, 10 tests, and we could easily say, all right, well, we'll add some additional tests, like, we'll add another test to do the maximum calculation, and we'll add tests to cover every decision table rule at least once by itself, but that's probably going to get us up into 16, 17 tests. Now we go back to the decision table. What if I say, well, I'm going to test each rule by itself, so there's 8 tests, and then I'm going to test each of the non-exclusive rules, rules 1 through 4, in combination with 5 through 8. So I'm going to go 1 with 5, 2 with 6, 3 with 7, and 4 with 8. So now I've got 12 tests, and then I'm going to have one last test where I combine 1, 2, 3, and 4 with 8, thus forcing the maximum fine. So now that's 13 tests total, which would be less tests than I have here. And I've tested some interesting interactions, and I've also tested the maximum. So, you know, is that really is this pairwise set of tests augmented, as I described, actually going to be better than the set of tests that I could just derive by going directly using decision tables and domain analysis? Well, it's obviously easier to do because you just throw it in the tool and you don't stop and think about what the logic is telling you and what's going on behind the screen. But is that really what we want as testers, or do we want to have our brain fully engaged when we're doing things? So, you know, a good question here is why the gap, right? And the reason for the gap goes back to something I discussed at the beginning, which is that in the pairwise techniques, the assumption is that there is no deliberate interaction between the different factors. The factors are independent. Okay, but if you think of the example that we just looked at, there are definitely interactions. There are both implicit and explicit interactions that go on. So, for example, you know, you're not going to get arrested 3 times if we go back here and look at the table. If 1, 2, and 8 all apply, you're only going to get handcuffed once. So, and that's an explicit interaction. Implicit interactions are like the additive nature of the fines. So, you know, if you think of again looking back at the table, the maximum fine here is when rules 1 through 4 apply plus rule 8. So that would be a $800 fine that would be calculated. So domain analysis and decision tables will force the testing of interaction because that's what they're specifically about. They're about looking at the ways that things interact and testing based on those interactions. But in the case of pairwise techniques, while you're looking for unintended interactions that might occur, that's the whole point of testing the combinations. It's not going to force tests that exploit the deliberate implicit or explicit interactions because the underlying assumption is there aren't any. Okay, so so pairwise testing maybe isn't the greatest fit when we're testing business logic, where there are interactions and the interactions are desirable interactions. So maybe we should think about other possible uses. Maybe well, you know, compatibility testing is a situation where you've got factors or variables that are supposed to be completely independent and they're not really supposed to interact. So maybe compatibility testing is a good fit for this. So you think about the RBCS website, we could say that there are 4 factors with 2, 3, or 4 options as shown here. We could have low-speed connection or high-speed connection. We could do Mac, Linux, Windows 7, Windows 8 operating systems. For security, we could rely on the operating system alone. We could use Symantec's package, Trend Micros, or McAfee. And then for the browser, we might use Firefox, Internet Explorer, and Safari. So if we plug all this stuff into the AXE tool, then what we come up with is this set of 16 tests, which, you know, logically enough, it would be 16, right? Because your 2 maximum sets of options is 4 and 4, so 4 times 4 is 16. So that makes perfect sense. Allows us to check, you to see what happens with each possible combination of connection speed with OS, connection speed with security package, connection speed with browser, OS with security package, OS with browser, and security package with browser. So if there's any unintended interactions there, we would catch them. So, okay, maybe that's good. It's 16 tests. And we would, find any of those unintended interactions that could occur in those 16 tests. But, play devil's advocate here. Is this actually worth doing? So what if we did equivalence partitioning? Now I shift the tool into pure equivalence partition mode and have it fire off that. And you see here that we can do this in 4 tests, which makes sense because when the equivalence partitioning, whichever of the variables has the maximum number of equivalence partitions is going to determine the number of tests. So every option gets tested at least once. We do test some interactions, not all possible pairs of interactions, but there are some interactions that are tested, of course. We've got 4 rows there. So, obviously this is weaker, but then on the other hand, it's a quarter the number of tests. Now you might say, well, 16 tests isn't that many. It's only 12 more. But yeah, but what if you go and applying pairwise techniques to everything you do, and rather than starting with equivalence partitioning, then you could be potentially quadrupling the size of your test set. Though of course what's actually going to happen, you won't quadruple the size of your test set. There's just other stuff that you will end up not testing. And you have to think about that. Every test you run represents a very large number of tests that you don't run. So do we actually need to spend the energy on the 12 additional tests to do the pairwise testing in this situation, or are there other tests, are there 12 other tests that would be more valuable than those? Excuse me, I had to get a drink of water there. Or maybe this is not maybe this is a false dichotomy. Maybe it's not an either-or situation, as life rarely does present us with either-ors. Maybe what we want to do is say, all right, there's some of these factors that I'm actually particularly worried about. Like maybe I think that browser and security software are particularly likely to have some untoward interactions. I'm not so worried about connection speed and operating system, but browser and security software, yes. Now, of course, in that case, this is not necessarily going to help us that much because there are 4 options for security, as you see here. Oops, pardon me. See, let me get this highlighter here. Excuse me. You got 4 options for security and 3 options for browser. So we're going to have 12 tests total if we test the combinations there. But still, that's less than 16. And anything we can do to reduce the number of tests and achieve the same degree of risk mitigation makes us more efficient and frees up time to focus on things that are perhaps more important than those 4 additional configuration combinations would be. So this gets us into, of course, the realm of risk-based testing and thinking about risk at a tactical level when we're doing test design. To make sure that our tests are as efficient as possible. Now, if, again, you're going risk-based testing, gee, that sounds really interesting. What is risk-based testing? Then what I would suggest is that you go out to the digital library again, and there's various recordings out there that have to do with risk-based testing, as well as a webinar. Plus, if you go to the articles page, there's an article that describes risk-based testing and implementation of it. And, of course, this is described in many places in my books as well. So what I'm suggesting here is that the indiscriminate application of pairwise testing techniques is not a risk-aware approach and is really something that we'd want to avoid. Now, since this is an interesting and somewhat charged topic to a lot of people, I decided to ask for some comments on this presentation. So I sent it out to someone who I know to be somewhat skeptical about pairwise techniques, as well as a couple of folks who are more supportive of them. And so here we can see Cam Kaner, who has been skeptical about these techniques for much the same reasons that I am over the years. And I want to highlight some of the things that he said in his comments. So he says lack of a theory of error, and basically this gets back to this issue of we're just blindly testing interactions, but we don't have any reason to suspect those interactions of being particularly likely to result in failures. So we're just going, well, maybe something's wrong, and that gets us into the dangerous ground of just testing whatever comes to mind without any sort of likelihood that there's going to be a problem there. The other thing that he mentions here is lack of an oracle. Now, what he means by that is that since there's not supposed to be any interaction, it's hard to know what you're looking for exactly. You're looking for it not to interact, yes, but how would you know that an interaction was present? What would you be looking for to see an interaction? So he gives this interesting example and talks about testing this calendar creator program. And if you set high-res video and high-res print outlook, that can cause a crash, but you have to do a print preview. Now, what would make you think to do a print preview? How would you know that not only do I have to set these two options together, which all pairs would have you do, but you'd have to also know that I need to do a print preview. You certainly aren't going to try every single possible action in the course of looking for interactions. And because you have no, as Kaner puts it, theory of error, you've got no way of knowing where to start. You don't know what you're supposed to suspect is wrong. You just say, well, it's possible something is wrong. So thinking back on the website example that I gave earlier, okay, I'm going to set up 16 different configurations that have all the possible pairs of options across the four different factors, but then what? What am I going to do with that? Now, one of the ways of approaching this is to split your test evenly across the different configurations and just run all of your functional and non-functional, in some cases, functional and non-functional tests across all those different configuration combinations, and just hope that if there are undesirable interactions, you stumble across them. But this gets us back into the land of random, and a lot of the point of systematic software testing is to escape the land of random, because especially if we're talking about human testing, the land of random is not good. Now, there's place for random testing techniques, pairwise, or dumb monkey techniques, for example. But when you start talking about manual techniques and sort of just a random search for patterns of misbehavior, that's not the world's most productive scenario. So that's the downside, if you will. Now, I also got comments from a couple fellows, Robin Jewell and James Nazar. And Robin and James work for the United States Department of Defense. I can't tell you what they do, but I can assure you that it is very important. And in addition, these guys are very smart, and they wouldn't be applying these techniques if they didn't see real value in them. So I want to give Robin and James a chance to sort of speak on the intelligent application of pairwise testing, which I think is a good place to get to here. Otherwise, it might sound like I spent this entire brief webinar just bashing pairwise techniques, which was not what I meant to do. Spelling myths is not the same as saying there is no intelligent application of the techniques. So Robin's comment here says, consider pairwise techniques as part of a larger mix of test design techniques. You might not do all of the rows, but you can very easily create a pairwise table and then say, okay, if I am at liberty to do, say, only 12 out of the 16 configurations, which 12 are the most interesting? So that's certainly a way to do it, to basically say, yeah, I don't want to be random, but on the other hand, I want to enlist luck in my testing efforts, and by using a technique like Pairwise, then there actually is some method to it with respect to what it guarantees, and you can do some research on what's called design of experiments if you want to see what that is. So maybe it's a good idea to use that as a basis for how I pick tests, even if I don't end up choosing or exercising all of the pairwise combinations. Excuse me, need a little more water there. And James made a somewhat similar comment. He said that what I can do is start off with equivalence partitioning and boundary value analysis, and then use techniques like pairwise testing or classification trees, and using that just to kind of think about, what do I want to test, what are the constraints, how do these things interact, how might they interact, what's the real world usage, what haven't we tested. So he's using this as not just as the test design technique, but part of how he goes through a careful process of designing tests. And he says that you might decide to go with decision tables or domain analysis, as I discussed, but it's a good idea to lay all the options out and look at what they would result in before you make that final decision. And so I think that's of course wise too, right? That don't leap to a conclusion and go, oh, I should always use technique X in situation Y, but rather say, well, in any given situation, I'm going to look at the different techniques that are available to me and the different levels of risk that are associated with this thing that I'm testing, and try to make a smart decision about what to do and what not to do. So I think these are two very good comments, good perspectives on this, and I think that this is probably a good place to come down on pairwise testing. Let's not, as the saying goes, throw the baby out with the bathwater, as it were. Oops, I'm sorry. I have no idea why I just did that. Okay, so since it is a Friday, I kept this one short and sweet. So conclusions, certainly there's been a lot of overhype. There are some overpriced tools out there and some people making some big promises on behalf of pairwise testing. I saw a gentleman give a presentation on pairwise techniques in Kuala Lumpur at a conference a couple weeks ago, and certainly it was a fine presentation from a purely technical point of view, but he seemed perhaps unaware of some of the limitations, and I think somebody sitting in the audience there might have come away going, wow, this is great, I should do this all the time. But I think the hype can be a little dangerous, so let's be careful. When we talk about techniques, we should talk not only about the great things they can do for us, but also situations in which they might be inappropriate. We should always consider all of the different options that we have when we're doing test design, not just so, hey, great, I've got this cool pairwise tool and I'm going to use it, because, as the joke goes, you give a child a hammer and the whole world becomes a nail. So you don't want to be the child walking around swinging your pairwise hammer at things, meanwhile other important stuff ends up not being tested. Certainly, if you've got a situation where there are deliberate interactions, and it is possible to analyze those interactions, decision tables and or domain analysis are a much more logical type of test design techniques to use, because they're going to focus you in on testing the interactions themselves. Now, if you do use pairwise techniques, keep in mind that because the technique is just going to say, okay, these are the things to combine, you still have to figure out what other actions to take, what kind of commands to try, the other kinds of inputs and test data that you're going to want to use, and also what is the expected result. You have to have some sort of oracle so that you can determine what the result of the test ought to be. So in some cases, it's probably as a starting point, I think probably in many cases, makes sense to do equivalence partitioning and boundary value first, since you'd need to do those probably as the basis for the decision table or domain analysis anyway, and then think about, okay, which path do I go? Do I go pairwise? Do I go decision tables? Do I go domain analysis? Do I do some mix of all three? How do I want to go about it? Just going through the process of identifying the equivalence partitions and the boundary values will help clarify your thinking about what you're dealing with, and put you in a good position to make a more intelligent decision about which other techniques to apply. So, as always, I put the advertisement up while undocking the question panel here. Let's see. So Benia sent in this comment, 5 to the 11th power. Actually, it was 5 to the 9th power because we counted 9 fields here. 1, 2, 3, 4, 5, 6, 7, 8, 9. So it was just a demonstration, and of course you might have counted the fields differently, Benia. The point being that whether it's 5 to the 9th or 5 to the 11th, it's an absurdly large number of tests, and we're not going to do it. So Niranjan asks, is pairwise testing suggested for end-to-end scenarios, particularly in component integration cases? Well, the problem that you're going to have, Niranjan, with doing this is again, knowing what actions to take. Now, it may be the case that the technique and what you're doing with it is you're actually combining actions together, and so you're getting the actions out of it. But in many cases it would not. So this would just potentially get you back to the Oracle problem that Kem Kainer brought up. Now, if you can solve that, this is potentially interesting, and in fact, I'm going to be talking to a client next week about this very thing, the possible use of pairwise testing in situations where you have lots of different components that can get tied together and be configured in different ways, and in integrating those components, can we use pairwise techniques? So I guess the answer here would be somewhat of a limited yes, in the sense of you can do it, but you'd have to be careful how you did it. You'd have to apply some real intelligence to how you went about it. AJ says, what does Mr. Black? You can just call me Rex. What do you think about first creating the pairwise tables and then applying risk-based approach and choosing the test to execute? Yeah, sure, you can do that because the tools make it so easy to generate the pairwise tables that there's no harm in actually just throwing the stuff in there. I mean, all of the tables that I showed you in this presentation were all thrown together in the space of, I don't know, probably 5 minutes or less. So, if you're in the middle of designing tests and you're like, wow, look, I've got options and they're supposed to be independent, why don't I'll just throw them into the AXE tool and see what it tells me, then, yeah, by all means do that. But just don't feel like, having generated the pairwise table, you're now, a slave to the thing, and you have to test the pairs. It's one input that could potentially be useful and interesting. Rajneesh says, thank you, Rex. Great presentation. You're quite welcome. Thanks for the kind words. Can I get a copy of this presentation for future reference? Okay, 2 sources. There's the digital library, where it will be posted in a recorded form, and you can always go out and listen to it. This very session is the one that's going to be recorded and posted there. It will probably be up within about a week and a half. I'm going to Paris and might have some challenges in terms of getting the recording back to the home office from there, but I'd say a week and a half it'll be up there. If you just want to look at the slides, pass the slides around as a reference to people, then you can go find a link to the presentation, which is on the RBCS website. So go to rbcs-us.com, navigate to the Resources tab, which is in the upper middle, navigate from there to the Basic Library, and you can find PDF versions of the slides on that page. So you can just forward that link around to your various folks, and they can then take a look at it. Okay, so I got a comment here from Alvaro. It says, we use the ACTS tool to apply pairwise testing. We first do equivalence partitioning, boundary value analysis, and domain analysis. With that, we develop a base set of test cases. This test cases then get loaded into ACTS to complete the test set to match the pairwise criteria. Doing this has helped us find voids in the requirement specifications for scenarios that are possible, but the behavior is not clearly specified, ending up in requesting improvements in requirements. Would you consider this as a good practice? Okay, so it sounds like you're doing this almost as much as a form of static analysis of the requirements as generating tests that will be run. And that is certainly an interesting perspective. Of course, this kind of concept goes back to Boris Beiser's comment in, I believe it was Software Test Techniques, where he said that sometimes, as he put it in his inimitable style, the threat of a test is enough. So basically, he was suggesting that you go and you tell the developers, look, we're thinking of testing this, or you go to the business analyst and you say, hey, look, we were thinking of testing this and it's not clear what's supposed to happen. And that might lead to filling of the gaps. Now then the question that I would have here is, well, okay, that's great, but it sounds like, I mean, I would think if you're applying domain analysis and pairwise techniques, that might result in a fairly large number of tests. Do you then use some sort of risk analysis to try to figure out which of those are the highest risk tests, and to start with that, and then if that proves to be productive of locates defects, then you decide, okay, well, we're going to run the rest of them, or you just go ahead and run all of them, because it seems like the volume of tests could be very high. So that's kind of what my thoughts on that, Alvaro. So Brett says, I'm left feeling like you think there is rarely, if ever, a time where pairwise would be the best choice. Is it generally a test technique you avoid then on your testing projects? No, I did not intend to leave that impression at all. The impression that I wanted to leave, which I hope I have, is that this is a technique which has its uses, but is often advocated in situations where it's difficult to use or not as useful as other techniques. I guess what I'm trying to achieve here is some sort of balance between what I consider to be a currently overhyped situation where somebody made a posting about 5 years ago saying, oh, this pairwise stuff is just the best technique to ever come along, and this wasn't even a tool vendor, this was just some guy, and I thought, well, that's kind of adulatory. I wouldn't say that it has the best technique ever to come along. I think equivalence partitioning and boundary value analysis are far closer to universal techniques. Pairwise certainly has its purposes, but it is, those circumstances would be more limited, say, than equivalence partitioning and boundary value analysis. But nevertheless, in the right situation, in a situation where, say, I was doing compatibility testing, I had reason to be worried about interactions because there was a history of that and it had proven impossible to figure out how those interactions were going to occur, and I had some way of identifying which particular actions would be good at sparking those interaction failures if they could potentially happen, then by all means I would use pairwise testing for that in a heartbeat, as long as I, as I said, had a way of figuring out what was the right thing to do once I had generated the pairwise table. So Niranjan says, pairwise is typically two-way interactions between factors. Not all factors will be of the same priority or relevance. Wouldn't mixed strength test cases help us resolve some of the issues with pairwise? Well, by all means, yes, Niranjan. And I believe the ACTS tool allows you to do that, to specify which of the variables you want to test in combination, and which you're okay with just having the equivalence partitions represented at least once in a configuration. So I think that's the smarter way of going about it. And I mentioned this earlier when we were talking about the RBCS website. I said maybe we're only interested in the security software and the browsers as interaction. So that would be a situation where we're using mixed strength. Let's see. Babatundi says, how can you determine how effective is pairwise testing on a project? Well, that's kind of an interesting question, because now you're asking about a more general question, I think, which is, how do we determine the effectiveness and efficiency of any given test design technique in the context of a project? Now, of course, the blunt way to do this is to classify your tests based on the test design techniques used to create them. And in some cases, a single test might fall into more than one category, so it'd get basically counted twice, as it were, and then count up the number of bugs found by each classification technique and divide that by the number of tests using it and come up with some metric of, bugs per test by technique. And if you want to make that a little more sophisticated, you could weight the bugs by priority and severity, and then have some kind of way of looking at that. But the problem with that metric, easy enough to calculate, but like it's the old H.L. Mencken quote of, for every complicated question or complicated problem, there's a solution that is simple and obvious and wrong. And the thing that's wrong with that metric is it only captures the bug finding effectiveness. So it's a measure of its technical risk, if you will, rather than anything else. And plus, since the technique would potentially have been chosen without too much consideration of where the bugs would be likely to occur, it might be just as much about impact as anything else, that that might even give you wrong answers, that metric would. So I think it's really a matter of using a more subtle kind of way of thinking about the question of which technique is going to generate the right number of test cases for a particular condition or situation, given the level of risk associated with that situation or condition. So right number being neither too many nor too few. And then also, which of the test techniques is going to generate a set of tests which is going to effectively mitigate the risks associated with that particular situation or condition. And I'm not sure that you can reduce that to a number. So I don't know that there's an easy way of evaluating that. Silvio asks, pairwise testing can be used for system integration tests. Yes, certainly it could be. And in fact, I've done that, where you're looking at systems of systems and you want to test different combinations. And as I said, I'm actually going to be working with a client this week on something very much like that. So yes, pairwise testing, like really all of the techniques, all of the test design techniques, can potentially be used at any level of testing. It's the way to think of these test design techniques is that they're just like tools in your toolbox, and you select the right one based on what your needs are, and that the level of testing doesn't always often doesn't even come into it. So Samir says, this is Samir Nandi. Nice to listen to you again. Thank you, Samir. My question is, the issue with pairwise testing that is described in Campaigner, can it be solved with taking more than a pair? And in that case, the number of test cases will be high. No, if you're saying, like, what if I go after triples or quadruples or quintuples, etc.? No, that doesn't make the problem go away at all. What Kaner was talking about is that there is, as he said, there's no theory of error. So in other words, you've got no reason to suspect interaction in any particular case, and thus you have no way of sort of thinking about which particular combinations are likely to create problems, and thus you don't know what to test. And you also then discussed the whole oracle problem, which is, even if you had some inkling of what to test, you wouldn't necessarily know what the expected result of the test would be. So no, that does not solve Kaner's concerns, unfortunately. Alvaro followed up by saying, we normally run all of them. We have an automated test environment. Thanks for your comments, Rex. Now that does change the situation, because if you have an automated test environment where you're able to churn out a large number of tests and run those tests very quickly, then that does definitely change the calculations with this, because it makes it possible to run a much larger number. Now, the thing with the automated tests is, of course, you've got to think about this whole oracle problem that Kaner was talking about, as well as the theory of error problem that he talked about, and make sure that your tests are actually going to be able to reveal bugs in that case. Okay, so an email question. Can you recommend any tools? Now, usually I do not. If you've ever heard me give these presentations before, usually I will not recommend tools without careful evaluation. But if you have already decided that you need to do pairwise testing, you need to have a tool available. I actually will, in this case, recommend the NIST tool, that ACTS tool that we looked at. I found it to be, of the different pairwise tools I've looked at, very useful. And it's I think it was certainly good value for money, given that it costs nothing. But as I said, if you're a U.S. taxpayer, you actually did already pay for it. So another email question. What does it mean when you say everything you choose to test represents an enormous number of tests you've chosen not to run? Basically, what that means is that one of the fundamental problems of test management is selection, which is that there's a almost infinite number, or actually infinite number, of tests that you can run. And when you choose a test, it's basically standing in for a bunch of other tests that effectively now are being left behind. So it's basically, you're going to select out of this huge infinite cloud of tests that you could run, this relatively infinitesimally small subset of tests, and then the question is, is that the right subset? So then that gets us to risk-based testing, and you'd want to take a look at what I wrote or said about that in some of the webinars, articles, and videos on risk-based testing. Another question, does pairwise testing have a place in Agile? Yes, life cycles should have absolutely nothing to do with the test design choices. They certainly influence the way that you choose to document your tests. You're going to be more lightweight in your documentation in an Agile environment than you would in some more traditional environments. Other things that can influence your documentation would be whether you're distributing the testing across multiple locations or doing it all in one place. But nevertheless, yes.